Okay, this video will be on Trigo differentiation. Before I go through differentiation, it's important to know the formulas for trigonometry. In your calculator, there's only sine, cosine, and tangent. So if I'm given cosecant x, secant x, and cotangent x, I may need to use the basic ones. I will need to use my sine, cosine, and tangent for my cosecant, secant, and cotangent. So we will take the reciprocal of the basic trigo functions. Now we come to the main highlight. Okay, what are my derivatives of sine x, cosine x, and tangent? There are three formulas that you need to remember. When I differentiate sine, it becomes cosine. When I differentiate cosine, I get negative sine x. When I differentiate tangent, it becomes secant square x. You have to remember this. And don't forget that we will still refer to the rules of differentiation that we have learned: power rule, chain rule, product rule, and quotient rule. Let's look at some questions, and I'm looking at question A, 3 tangent x minus 2 sine x. Okay, if I want to, okay, it's better to put a y equals in front of it. Okay, let's differentiate this. So for this question, I will leave the 3, differentiate tangent x. Differentiate tangent x give me secant square x. Okay, minus 2, I will keep it. I will differentiate sine x. Differentiate sine x will give me cosine x. This is the answer. Now I take a look at part B. Okay, what rule will you use? So this question is a product of two functions, 3x power 5 and sine x. Means what rule must we use? Product rule. And in product rule, remember, differentiate first. 15x squared. Keep the second. Plus, keep the first. And I differentiate the second. What happens when I differentiate sine x? Cosine x. Okay, and thank you very much for spotting my mistake. Instead of 2, it will be a 4. Okay, bring down power, power minus 1. Thank you very much. Of course, I can also simplify. Okay, actually you can stop here. This is a method mark. But some of you may want to further on, okay, continue on and simplify. Take out common factor. If I factorize, there will be an x there. Okay, when I have this next function, it looks like a fraction and it can't be simplified. So how? When I differentiate, what rule should I use? Quotient rule. Thank you. Differentiate the top first. When I differentiate cosine x, what do I get? Negative sine x. Keep the bottom. Minus. Keep the top, and I differentiate the bottom, I will get 5. Over bottom square. So this is quotient rule. And I must make a further move. I must simplify everything. So actually for the first one, you don't need to simplify if you don't want. But you really need to simplify the second, because I can have a number times another number. 2 times 5, I can get 10. We are very cool with this, okay? Let's just leave it like this. Let's move on to this. Okay, what rule will you use when I see this function here? Must use power rule, yes. I see a power, I can start bringing down power minus 1. So let me do that. If I differentiate, I must use f prime. Bring down power, power minus 1. Are we done like this? What must we do? Third step. Differentiate terms inside. So I must put a big bracket. Differentiate 3x becomes 3. Be careful, I differentiate cosine x. It will give me what? Negative negative sine x. So like this. We can leave it like this. If you want to expand, go ahead. But honestly, you don't need. You can just leave it like this. Okay, leave it. Very simple. Okay. Okay, now I'll take a look at this function. X over tangent x. Come, class. What rule shall we use for this? If I can't simplify the fraction further, quotient rule. You guys have good intuition. Quotient rule, because I see the fraction. Okay. But the thing is that I'm not done, class, after I do quotient rule. Because I need to show that it looks like this. Oh dear, how? It means I need to do some manipulation. And I know cotangent is something. It's related to one of the basic trigos. Cotangent is actually what? 1 over tangent x. Cosecant, Cosecant is 1 over sine, but there's a square here. So I should have this, right? So I need to create all these terms in my answer over here. And you see, one fraction I break into 2 terms. Means what should be the next step? I must break the fraction up. Yes. So when I break the fraction up, I must apply the same denominator on both of my numerators. Okay. First one, everyone can see I divide both by tangent. That's how I get my 1 over tangent x. But this one, there's no common factor, so I must change it up. Secant x, right? And tangent x. Okay, I know tangent x is sine over cosine. Of course, I need to put the square. But my numerator, secant square x can be simplified to what? 1 over cosine square. And I know it's a divide. Okay? Numerator divide by denominator. Oh, but if I don't like divide, can I do keep change flip? Maybe make my life easier, right? If I do keep change flip. So this is how it will look like. Also, x times the fraction. Actually, it's just the numerator multiplied together. After I do keep change flip, okay, notice how I do keep change flip. I see that I can cancel my numerator, my denominator. So what I have is this. Now I will change back to what they want. Cotangent x minus x cosecant square x. You will tell me what's my a and b then. What is my a and b? A equals to 1 and b equals to -1. Yes.